Loops, loops, loops everywhere. We've done loops in Python. We've done loops in Java. Look at this. This looks very much like Java. One difference, and I only put this in here because it's a more modern way to initialize a variable in C++. This creates the variable first and then assigns the value to it, where this assigns the value while initializing the variable. Is there any difference between those two? No. This is just a more modern way to assign an initial value to a variable. So for create our counter variable, have our test, plus plus, well, that's not going to take too long to go through. The only difference is how we display things. Otherwise, it's very much the same. So we have for loops when we know pretty much how many times we're going to go through it. Very popular loop. When we're not sure how long we want to go through something, we use a while loop. A while loop may not ever run. So we have two different types of while loops. We have a do while loop. A do while loop is what's called a post-test loop, meaning it will run at least once and then do the test. The while loop does the test at the beginning, so if our counter variable is, for example, 11, the loop never runs because 11 is not less than 10. So it would depend on what you're doing. I've rarely ever run a loop. Well, if you have input from the user, it's certainly possible. Yeah. It doesn't happen terribly often. Anyway, so a do while means we're going to go through it at least once. It's called a post-test loop because we test it after we do the loop. And excuse me, the syntax is very much the same. When we're doing a do while and a while loop, we have to initialize and create our own counter variable. And the same thing here, we initialize our own counter variable. I should make that the same, shouldn't I? Initialize counter variable. There. There's our three main loops. Now, what do we use loops for? Well, there's some things that we've learned to do with loops that we should look at. What's a break for? Well, we've been using it quite often to do menus. So while count is 0, while count is less than 10, we keep testing. Well, in this case, when the count equals 5, we break out of the loop. Oh, I'm in break, not continue. I'm in break. So this breaks us out of the loop. So this would be, for example, if a user enters 5, they do this. If they enter 7, they do this. When they enter something else, we exit the loop. We've used this a lot, break a lot for menu loops. Now continue is a horse of a different color. It's, interestingly enough, exactly different. Let's see. For some reason I did not finish that, I'm guessing. Anyway. Oh, looks like I didn't print out my variable. Oh no, I did count out the variable. What I'm doing is I'm printing out every even number with this one. That's what that's doing. I should put that in there, printing all the even numbers. Well, let's prove it, make sure it works, and I'm not giving you terminal. Let's run up a new terminal. And our program is continue. There we go. We need exe. That's what it's doing. It's doing all the even numbers, including 0. Well, we could clip out 0 if we wanted to, but... So what happens is the count starts at 0. If the count modulus 2 is not equal to 0, we add to our count. And we continue through the loop. Right? Continue means that we keep going. However, if this doesn't test right, well, we print out a space. We print out the count in the space. So the count increments this time if it's not even. It prints if it is even. So continue zips us around to the beginning, where break just kills us and cuts us out. So the first time around we have 0, it does not meet the specification. Print it. 1 does meet the specification. We add 1 to it, continue. Jump by this, go back to the beginning. We end up with 0, 2, 4, 6, 8. We stop at 10. Why is that? Because we don't have less than or equal to. or I could say less than 10. At this point, we stop at 9. We could fix all that up. We could start and just get even numbers by changing this to 1. And we could do less than or equal to, right? If we wanted to go from 0 to 10. But that does mean I need to compile this thing. Where's my build task? There it is. And it's connecting. It's doing all kinds of things down there. It's because I have a couple different. All right, so here is my, there it is, Ming64. Yep, everybody's happy. Bring up the terminal. And continue. There it is, 2, 4, 6, 8, 10. So there's some pieces of it. Now, how do we use these guys? Well, this is one of my favorite little programs. Who doesn't love a blast off, right? Well, to do a blast off with time in it, we don't have a time library as such that's universal in C++. Who knows why? They just don't. So we end up having to include things, and we have to include things for the two main operating systems. Something's either Linux-based or it's Windows-based. That's pretty much all we have anymore. So we're starting a for loop, and this allows us to create our sleep function. I mean, it gives us our sleep function. That's inside this. Sleep is inside this. So this pauses for 1,000 milliseconds. And then it prints blast off. So is that what we want to use loops for? Sure. What's wrong with doing a loop? What's different about this? Oh, the only thing that's different is we're going backwards. We're counting down. 0, 9, 8. Okay, well, here's another interesting one that I worked on a little bit. This is how to use threading in C++, which you can see was kind of interesting. You have to have a library for thread control, and then I had to simulate things going on, so I used the sleep4 library, or chrono. So anyway, we start our program, we start through our loop, we're going to create a main program. We're going to pause the main program thread for 1,000 milliseconds to create a delay. So we're not creating something with threading, we're doing a very complicated sleep. Okay, well, this is cross-platform. This will allow us to sleep for so many milliseconds. I forgot this had nothing to do with thread control. It does have to do with thread control. Every program we've written has one main program thread. We haven't dealt with multiple threads yet, but we're going to. Maybe next semester. Because when you get extra threads going, then things can become interesting. We are pausing the main thread, which is the program that's running in, for 1,000 milliseconds. This is a little more complicated than the other one, but it is cross-platform. It'll work on anything that has a standard C++ compiler. Forgot about that one. What else do we have here? Oh, input validation. Running total is one that we've done before. We have a running total. We have a number that users are entering. We enter the number. We do plus equals. Ooh, that's not any different than stuff we've done before. Running total, no problem. What else do we have here? Nested loops are always fun. We have a loop, and then inside that loop we have another loop. Well, when would we use this? Well, we haven't gotten to that yet, but when we do two-dimensional arrays, they are set up for nested loops. This is a demo of a nested loop showing when something happens. So this goes through this once, then it hits this, goes through this 5 times, then it increments this one. I guess a picture is worth 1,000 words, or a run of the program is worth 1,000 words. So let's do nested loops. There. So here's our exterior loop. This is its first iteration. The interior loop goes 1, 2, 3, 4, 5 times. Then we come back up to the exterior loop one more time. We move down one, so to speak. Count out the same thing in the middle. Move to the last. Count out the same thing in the middle. So this works really good for matrix. Like tic-tac-toe is one of the most famous matrices in computer programming. If you want a challenge, create a tic-tac-toe program in C++, a text C++ program. Pretty exciting. Well, not exciting, but it is a good challenge for learning how to use two-dimensional arrays, which we will get to. All right, so how do we do input validation? Well, we do the same thing we've done before, except we have to, when we get this, we have to specify, instead of just cin, we're wanting to get in a string, right? Well, we don't want to get a string. It starts out being a string, right? Cin string. So we're typing in the number 1, that's a string. Then we want to cast it. STOI is, I think it's part of the standard library, isn't it? No, I think it's probably part of the string library. So then we cast it to an integer. If that blows up, we can catch it and then say, oh, sorry. And you know what continue does? It continue starts again until you get it right. So far, so good. So this is one thing that's a little bit, no, it's standard. I don't know what the SIO stands for. Anyway, it takes a string and changes it to it. And what we've done in the past is we'll get in the string and then cast it to an integer. All right, I just wanted to introduce this as one of the reasons I put that in there. Well, that pretty much covers all of our loop-de-loos. Now, when I was writing this assignment, I don't remember when it was, 2 or 3 years ago, Indiana Jones and the Temple of Doom had just come out. So I thought, oh, let's make this a guessing game and the Temple of Doom. If you can't win the game, then apparently you fall into the Temple of Doom. I don't know. Anyway, we're going to take what we've learned here, and yes, we're going to do another guessing game program or some other program that you want that has something to do with loops and numbers and things. Anyway, that's a good one to do. We know how to generate a random number. We know how to do a print title. We know how to get the user guess. We know how to determine if it's high or lower. We know how to track a running total. We know how to do all these things. So this is a good way to put a loop into a program that's not that hard, that we know how to do, because primarily we're here not to create a fancy program, but to learn looping and put things together, consolidate what we've been learning about C++. Please let me know if you have any questions.